Alright, so today we're gonna learn what is meant by column interpretation of matrix multiplication. So there are multiple ways how two matrices can be multiplied to get another matrix, and we're gonna see the column view of this multiplication. So for example, let's consider this thing. We have a matrix A and we have another matrix B, and as we multiply we get a matrix C. So we can write it this way: matrix A, matrix B, and as we multiply we get another matrix C. And so we can write this as M by N. This matrix is N by P, so our resultant matrix is M by P. Alright, so now if we write down in details of this matrix, we can write this way. So let's write this. So this element of matrix A is gonna be I1, row 1, and column 1. So we have m number of rows and n number of columns. So the second element is gonna be A, row 1, column 2. Like this, if we go, we can have the last one as A1, and the number of column is n, so it's gonna be n. So similarly, as we keep writing, the last element of this column is gonna be AM1. This is gonna be AM2. Again, this is gonna be AMN. Alright, so this is our matrix A. And then as I write, matrix B is gonna be similar. It's gonna be similar for matrix B. The number of rows are n and the columns are n for matrix B. So we start with B1, 1, B1, 2, and the last element is gonna be B1, P. Similarly, the last element is gonna be BN1, because the number of rows are n. This is gonna be BN2, and the last element is gonna be BNP. Alright. Okay. Oops. So this is gonna be equal to C. We write matrix C, which is M by P matrix. So let's write as this: 1, 1, C1, 2, and as we go, this is gonna be C1, P. But as we go, this is gonna be CM1, CM2. This is gonna be the last element, and that's CMP. Alright. So this is how it looks in details if we write out every single element. But here we need to see this, like multiply these in terms of the columns. So for that we need to do two things. First, we need to convert these guys into their columns and these guys into their columns. So let's do this. All right, so this is gonna be, now this thing, if I write it down, just do 1 second. So this thing, this whole column is gonna be, we can write it as a single element here. Let's just color all of this, and then we color this as well. Let's color this as well. All right, so this is gonna be, this first column, we can write it as A, and our varying element is the row, so let's write as I, and the column is number 1, so 1. And the second column we can write as A, I, 2. Similarly, the last one we can write A, I, N. All right, so if we color this again, so this is gonna be the first one, this is my second one, and this is my third one. This is my third one. Okay. Now we have this thing, we can just copy this thing, the whole thing. Let's just copy. All right. And then let's see this again from for the column for matrix C. We can color this similar way. Say we have this thing. We have this thing. This is the first column. And let's color something different. So this is the second column. Oh, so let's just change this. This is the second. It's the second column. So this is our last column, like this. And again, we can write this in the similar way. So equal. So this is gonna be C. So we can write CI1, CI2, and CIP. All right, so we have written everything for column A and C in column format, and then like it becomes interesting because for then we can represent column C in terms of A and B in such a way that the columns of C are the combinations of the columns of A. So how? For this, let's just do this. I'll have a pencil and like just say this thing. So this guy here, C1, is nothing but this guy multiplied by this guy. So we can write it CI1 equal to AI1 B11 plus AI2 B21 plus AIN BN1. So similarly, the second element, this thing, this one, C11, C12, it's gonna be this guy multiplied by this one. So we can write CI2 is equal to AI1 B12 AI2 B22 plus AIN BN2. And finally the last one, if we keep going like this last one, which is this last element, is gonna be again this guy multiplied by this one. So this is gonna be CIP equal AI1 B1P plus AI2 B2P plus AIN BNP. So that's how we can write it, and it's an interesting one because here we can see. Let's do this thing. We can see that C1, CI1, CI2, CIP, these are actually all nothing. These are just the columns of our matrix C, and we can get the columns of matrix C based on the columns of matrix A, which are these guys. And but the columns of matrix A will have some sort of combination. So AI1, AI2, AIN. So all these columns, they have some sort of combination. We can see this thing, this thing, this thing, and the weights are this: B11, B21, Bn1. So these weights are coming from matrix B. So from matrix B, we have the columns. The elements along the columns are coming to get multiplied by the columns of matrix A and working as weights to finally provide us the columns of matrix C. So similarly, as we go along the columns of matrix C, we will see that these are basically nothing, just a combination of the same columns of matrix A, but the weights are getting changed. The weights are getting determined by the elements of matrix B. So this is our summary. So as we can finally write down this thing. So this basically means that the columns of matrix C are combinations of the columns of matrix A. Let's write it this way. And we can also write that the elements along the columns of matrix B work as the weights of the combination to provide us the columns of matrix C in terms of the columns of matrix A.